Hello, Math 7 students. This is Unit 4, Lesson 3, Revisiting Proportional Relationships. Just as the lesson title suggests, we are revisiting a concept called proportional relationships, which we learned about a lot a couple units ago. We've moved on from that, but some of those same themes continue to pop up and are going to be really important for Unit 4. So today we're revisiting or reviewing. The objective today, let's use constant of proportionality to solve problems. Let's get started. I want you to think about it. What is the constant of proportionality? It's a question I haven't asked for a long time, but what is the constant of proportionality and how can I find it? Normally in class, I would ask students to call out. These are some things that I hope that you would have said. The constant of proportionality is the number that we multiply by as we go forwards across a table. So imagine we have a table of values, our X column and our Y column, and I want to know how we are going forwards across that table. Sometimes if the numbers are very nice and easy, like 3 changing to become a 6, I would ask, how does a 3 change to a 6? And we're looking for the way that it multiplies. The constant proportionality in this situation would be 2, because 3 times 2 is equal to 6. We're multiplying by 2 as we go forwards across the table. But sometimes, maybe our mental math skills aren't as strong, maybe we're feeling really tired and we're just not feeling as good, or maybe we've got some numbers that are a lot more difficult to work with. Like what if instead it was 4 changing to a 5? I might not be as good at a problem like that, remembering how a 4 changes to a 5. So what would I do if I don't know how to go forwards across the table? That's when I've always told you we would work backwards and divide. So if I'm not sure how to go forwards, instead I'm going to work backwards and divide. So I would start by typing in 5 divided by 4 into my calculator. 5 divided by 4 is the fraction 5/4, or the decimal 1.25. So again, that now tells me that 4 times 1.25 is equal to 5, or in other words, the constant of proportionality is 1.25 since I'm multiplying by 1.25 as I go forwards across the table. Let's go ahead and get started on the lesson. We start with the table that's partially filled out. And it says a recipe calls for 1/2 cup of sugar and 1 cup of flour. So I can see 1/2 cup of sugar and 1 cup of flour already listed in the table. Our job is to complete the table to show how much sugar and flour to use when I make different amounts of batches. So what if I only am using 3/4 cup of sugar? How much flour am I going to need? Or what if I'm using 1 3/4 cups of flour? How much sugar am I going to need? In order to answer this question, we have to remember, how am I going across the table? What is the constant of proportionality? Again, for some students, this might be a mental math problem, but in case it's not, anytime I don't know how to go forwards, I'm going to work backwards and divide. So I might need to type into my calculator 1 divided by 1/2, and that is going to give me the number 2. What that number actually tells me is we are actually going forwards in this table by multiplying by 2. So now I can confirm and double check in my calculator 1/2 times 2 should be equal to 1. 1/2 times 2 is equal to 1. And that tells me exactly how I'm going forward everywhere else in the table. So 3/4 is going to be multiplied by 2. Go ahead and use your calculators for that. 3/4 times 2 is equal to 1.5. And now we have to work backwards and divide. Because going forwards, I'm multiplying by 2, but I don't know what belongs here, so I can't go forwards by multiplying by 2. So when we have a situation like this, we should remember, going forwards, I multiply by 2. Going backwards, I need to divide by 2. So I need to type into my calculator 1 3/4 divided by 2, since I'm now working backwards, and that's going to give me the fraction 7/8. You're welcome to use decimals if you prefer. Another way that I could have done this problem If you can't remember how to type in the fraction 1 3/4 into your calculator, you can always make those conversions. 1 3/4 is equal to 1.75. So maybe instead, in my calculator, I would have typed in 1.75 divided by 2, and it would have given me 0.875. That is the same number as 7/8. We just have it in fraction form or in decimal form. Let's continue filling out the table. Following that constant proportionality, going forwards, I'm multiplying by 2. Going backwards, I would divide by 2. Using your calculator anytime you need to. We have 1 times 2 is 2, and 2.5 divided by 2 is 1.25. Again, if you decided to keep it as a fraction, 1.25 is the same as 5/4. Let's move on. Here it says 2 students are solving the same problem. At a hardware store, they can cut a length of rope off of a big roll, so you can buy any length you like. The cost for 6 feet of rope is $7.50. How much would you pay for 50 feet of rope? Kiran knows that he can solve the problem this way. He took the information from the story, 6 feet of rope, and he made it into a table with length of rope listed as 6. And that cost is $7.50. So the cost or price of the rope in dollars is $7.50. So he organized his information into a table. And he decided to do this. He says, I'm going to change this 6 to a 1. I'm going to find the unit rate. So one way that he did it is he multiplied by 1/6. The way that we have practiced in class more often is 6 can turn into a 1 by dividing by 6. And I need to make sure I do the same thing to both parts of my ratio, so I will also divide by 6. You can see Kiran multiplied by 1/6. Either way you do it, 6 divided by 6 is 1, and 750 divided by 6 is 125. Then we decide, now that I know that this is a 1, I can easily change a 1 into any other number. 1 times 50 is 50, so I should do the same thing here and also multiply by 50. So 1.25 times 50 is equal to 62.5 or 6250. But Kiran says he wants to do it in a more efficient way. He wants to see if he can do it in fewer steps. And Priya says, I can do this in one less row on the table. I don't need this row of ones. What is it that you think Priya did? And if you're thinking about the constant proportionality, you're exactly right. Instead of taking the time to go and find the unit rate, we can just find the constant of proportionality. How does a 6 change to a 7.5? I really don't know. But I do know that I can always find that information by working backwards and dividing. So in my calculator, I would type in 7.50 divided by 6. 7.50 divided by 6 is equal to 1.25. What that tells me is that I now know I'm going forwards in this table by multiplying by 1.25. So if I want to jump to 50 feet of rope, I don't need to find the unit rate. I can just go forwards across the table by multiplying by 1.25. So in my calculator, I would type in 50 times 1.25. And I'm going to get the same answer as we got before using Kiran's method, but I was able to do it in fewer steps, 6250. With that in mind, let's take a look at the next set of problems. In this next section, you're given 3 different problems. For 2 of these problems, a table has been provided. For the third, a table has not been provided, but you'll hopefully realize how helpful these tables are and maybe be able to set up your own table. What I want you to do is work through each of these problems on your own. That means I want you to pause the video and give them a try on your own first. After you've tried them on your own, then you'll play the video to check your answers. That means if you're watching this video with the substitute, please pause the video as the students give these a try. Pause the video now. Okay, let's go over these together. Tyler swims at a constant speed. That means he can swim 5 meters every 4 seconds. What we want to know is how long does it take him to swim 114 meters? So we can see that the table has already been set up. We have one label for distance measured in meters and another label for time measured in seconds. So we can see that 5 meters has been placed here in the meters column and 4 seconds has been placed here in the seconds column. You can see that we are no longer making a space in the table for the 1. We're not finding the unit rate. We want to just really focus on how am I going forwards in this table. So how does a 5 change to a 4? For me, that's not mental math. So I'm going to use a strategy where if I don't know how to go forwards, I work backwards and divide. So in my calculator, I will type in 4 divided by 5. When I do this, my calculator will either give me the fraction 4/5 or perhaps the decimal 0.8. What that tells me, when I work backwards and divide and I get one of these numbers, it now tells me how I'm going forwards. So I'm going forwards by multiplying by the fraction 4/5, or I'm going forwards by multiplying by 0 and 8/10, or 0.8. So let's go forwards in order to answer this question. 114 times 0.8 is equal to 91.2. And again, how did I get this number? I started here with the 114. I already know that I'm going forwards by multiplying by the fraction 4/5, or I'm going forwards by multiplying by 0.8. So I'm typing into my calculator 114 times 0.8, which is equal to 91.2. You're going to see that I have another row where there's an X. If you read all the way through all of the problems, you're going to see that for each one of these, I want you to write an equation. So an equation is where I'm still going forwards and I'm not changing my routine. I'm still multiplying by the exact same number. It's just I don't know what this is here. So I use the variable X. But it shouldn't change what we do. We're still going forwards across the table by multiplying by 0.8. So that means even if I start here with an X, I'm still going to go forwards by multiplying by 0.8. So what am I going to get when I do that? 0.8 X. That's not something I can type into my calculator, so it's something that we need to remember from when we practiced it a couple units ago. Let's take a look at number 2. I still have a table created for you, but I have not filled in the table with any information. So one of the labels is number of bottles of sparkling water, and another label is number of bottles of plain water. So when I read this, it says a factory produces 3 bottles of sparkling water for every 8 bottles of plain water. So I need to organize that information that it just gave me here in the table. 3 bottles of sparkling water, so here's the sparkling water, I'll put a 3. 8 bottles of plain water, here's the plain water, where I will put an 8. I want to know how many bottles of sparkling water does the company produce when it produces 600 bottles of plain water. So I know how much plain water is going to be there. That's supposed to be 600. What I want to know is how many bottles of sparkling water. So I need to figure out what's going to go here. In order to find that out, we once again need to figure out how I'm going forwards so that I know what I need to do to go backwards. So the first question I want to know is how does that 3 change to an 8? Once again, I don't know. It's not a mental math problem for me. So I'm going to use that strategy that if I don't know how to go forwards, I'm going to work backwards and divide. So I'm typing into my calculator 8 divided by 3. And 8 divided by 3, I hope that you recognize from our more recent lesson that when you get 2.666666666 and it ends with the 7, hopefully you recognize that this is really actually a repeating decimal that the calculator just happened to round. So one of the things that you can do is you can write this as 2.6 over bar. But even better, because I cannot get my calculator to do 2.6 over bar, instead, let's go back to the original form. 2.6 over bar is 8 divided by 3. But if I write that in a new form and write it like this, 8 divided by 3, now I have a rational number with the repeating decimal form, but this is the form that I can use in my calculator to produce correct answers. So what this means is when I am going forwards in this table, my constant of proportionality is 8/3. That tells me if I'm going forwards, I would be multiplying by 8/3. And that's great, except for in this problem, I don't want to go forwards, I want to go backwards. So the great news is, going forwards, I would multiply by 8/3. Let me try that again. Going forwards, I would multiply by 8/3. So that means going backwards, I'm going to divide by 8/3. So in my calculator, I'm going to type in 600. I'm working backwards, so I'm going to divide by 8/3. This is what I'm typing in. 600 divided by 8/3. When I do that, it is going to give me the number 225. Now, if, when you did this problem on your own, if you rounded 8 divided by 3 to just 2.6, then you would have gotten a very different number. So this is why it's important that instead of rounding, or instead of trying to type in a whole bunch of sixes, really think back to what does this number actually mean? It means 8 divided by 3, or the fraction 8/3. And when we use the fraction form of the number, it's a lot more accurate than rounding or trying to type in enough of those decimals. When we get to number 3, there is no table, but we've kind of baby stepped through this enough that hopefully you know how to create your own table. A certain shade of light blue paint is made by mixing 1.5 quarts of blue paint with 5 quarts of white paint. So how much white paint would I need to mix with 4 quarts of blue paint? There isn't a table, but this would make so much more sense if I could organize it into a table. So as I read it again, let's think about what my labels are going to be. A certain shade of light blue paint is made by mixing 1.5 quarts of blue with 5 quarts of white paint. That tells me what those labels should be. I'll have one column for blue paint and one column for white paint. So when I read it again, I'm mixing 1.5 quarts of blue. That tells me that the number for blue is going to be 1.5. Mixing that with 5 quarts of white paint. So that tells me the number for white is going to be 5. The question we're asking is how much white paint would I need to mix with 4 quarts of blue? So I have 4 quarts of blue. That means that there is going to be a 4 here. I just need to figure out what is going to be across from that. And the information that I need to find that out is back here. How does a 1.5 change to a 5? Once again, I don't know. So I'm going to work backwards and divide. In my calculator, I'm typing in 5 divided by 1.5. And I get the fraction 10/3. Remember, if you typed it into your calculator differently and it gave you a decimal, it would probably have given you the decimal 3.3 repeating, or we could write it as 3.3 over bar. So which version of this is going to be best? When I continue on with this problem, I'm going to have to multiply by that number. Now, I don't have the ability to type in 3.3 over bar. I don't have that option in my calculator. So I would have to type in 3.33333, as many threes as I could get. That could be really annoying. So that's why, even though it's nice to know these decimal approximations, sometimes it's better to just go with the fraction. So to sum it all up, we worked backwards and divided. 5 divided by 1.5 is equal to 10/3. What that tells me is the constant of proportionality is 10/3. I'm multiplying by 10/3 as I go forward. So I'm going to start here with the 4, go forwards by multiplying by 10/3. Let's go ahead and do that in our calculator. 4 times the fraction 10/3. And when I do that, I get 40/3, which is accurate, even if it is weird and awkward. The truth is, it is 40/3. Now, do I know exactly how much paint that is? No, and so forcing our calculator to give us a decimal approximation is a good idea. This is going to be 13.3 over bar, or 13.3 repeating. That tells me that when I use 4 quarts of blue, I'm going to need 13 1/3 quarts of white paint. There's one thing that we didn't quite finish up. This says, for each of the previous 3 situations, write an equation. I kind of did that, and I kind of got started back here on our first situation, but I didn't actually complete it. I did mention that even if I have x, a variable, I'm still going to go forward across the table in the same way, but this is not an equation. In order to make an equation, I'm going to complete the whole thought that if I start with x and I go forwards across the table by multiplying by 0.8, I am going to end up on the other side. But what is the label that I'm going to use? If I'm using an x here, then it makes sense that the label on the other side would be y. This is the equation that we're after. X times 0.8 equals y, or, as we have also practiced, writing it in the reverse form because mathematicians are lazy, and we would write y equals 0.8x. So what would our equation be for question number 2? Once again, I was going forwards across the table by multiplying by 8/3. So what am I going to do with this x? We're still going to go forwards across the table by multiplying by 8/3. So what's x times 8/3? Let's write it down. I'm running out of space here. Let's try this. X times 8/3 takes me all the way across the table. But what is the result? Well, once again, if I'm using x for my label, then the next column makes sense for it to be y. So x times 8/3 is equal to y. That would be our equation. For question 3, I haven't given you any labels at all, so it's a good idea to get in the habit of thinking about this. I could continue to use x and y, but since we're dealing with blue and white, we can also get creative and decide to use b for blue and w for white, in which case we would have the equation b is multiplied by 10/3 and is equal to the amount of white paint, or W. That would be our equation for our third situation. Let's continue on. We've got one more set of challenge problems. This next set of problems, once again, I would love for you to pause the recording and give it a try on your own. So again, guest teacher, go ahead and pause the video. Now that you've had a chance to give these a try on your own, let's take a look at them together. Lynn runs 2 3/4 miles in 2/5 of an hour. Tyler runs 8 2/3 of a mile in 4/3 of an hour. How long does it take each of them to run 10 miles at that rate? What I have to recognize here is that I have 2 different people, so I have 2 different situations. We have some information here about Lynn, and we have some information here about Tyler. So what I need to do is separate this. There's going to be 2 different tables. I will have a table where I talk about Lynn and a separate table where I talk about Tyler. Lynn runs 2 3/4 of a mile in 2/5 of an hour. So my column labels are going to be miles and hours. We have Lynn running 2 3/4 of a mile, and that takes Lynn 2/5 of an hour. We have Tyler, who has 8 2/3 of a mile and 4/3 of an hour. So once again, I need to find the constant of proportionality. This is definitely not mental math. I don't know how to go forwards in this table, so I am definitely going to work backwards and divide. So in my calculator, I'm typing in 2/5 divided by 2 3/4. If you haven't already done it, make sure you're doing it with me. I'm typing it into my calculator, so it takes a little bit of time. Again, I'm typing in 2/5 divided by 2 3/4, and I get this lovely number of 8/55. Once again, we can see a decimal version of this. I'm going to go ahead and use the fraction. We're multiplying by 8/55. So when it asks, how long is it going to take to run 10 miles? Now I'm going to take a 10 and put it in that column for miles, but I still know how I'm going forwards. I'm multiplying by 8/55. So 10 times 8/55 is equal to, again, you can decide fraction or you can decide decimal version here. The fraction, the one that's completely accurate, is 16/11 of an hour, but we don't really measure hours in 16/11. That's super weird. So it makes a lot more sense to say that this is about 1.45. 1.45 of an hour, or almost an hour and a half. Let's continue that same process for Tyler. Once again, I don't know how to go forward, so I'm going to work backwards and divide. So I'm typing into my calculator 4/3 divided by 8 2/3. Type it in with me if you haven't done so already. 4/3 divided by 8 2/3. And I got a fraction 2/13. So again, what that means is I'm going forwards across this table by multiplying by 2/13. So when I now am going to plug in a 10 again for 10 miles, I'm going to go forwards 10 times 2/3. Let's type that into our calculators. 10 times, not 2/3, sorry, 2/13. 10 times 2/13, I get the fraction of 20/13, which again is true, but it's weird. We don't say 20/13 of an hour. So I'm going to go ahead and convert that to a decimal, and I get that is about 1.54 hours. Who ends up being faster now that we have something that's similar to compare in 10 miles? Lynn. Or if Lynn is running 10 miles, it will take about 1.45 hours, where if Tyler is running 10 miles, it will take about 1.54. So we can see that Tyler takes a little bit longer, so Lynn is running faster. Let's move on to the last one, Priya. Priya mixes 2.5 cups of water with 1/3 cup of orange juice concentrate. And Diego mixes 1 2/3 cups of water with 1/4 cup of orange juice concentrate. How much concentrate should each of them mix with 100 cups of water? We want our juices to taste the same as the original mixture. So once again, I have 2 different stories, 2 different people, so I'm going to separate this. I'm going to have a spot where I can talk about Priya and a separate space where I can talk about Diego. I'm going to still set up my tables. And the information that I should be putting in the tables, we have water and orange juice concentrate. So water and OJ orange juice. Priya mixes 2.5 cups of water with 1/3 cup of OJ. Diego mixes 1 2/3 cups of water with 1/4 cup of OJ. And we want to know, what if they each are using 100 cups of water? So once again, we're finding the constant of proportionality. I don't know how to go forward, so I'm going to work backwards. Typing into my calculator 1/3 divided by 2.5. And that number is 2/15. So I'll be multiplying by 2/15, and 100 times 2/15 is equal to 40/3, or about, hold on. I'm just going to rearrange some of this a little bit. It's a little bit squishy. Let me just move some things around here. There we go. 100 times 2/15 was equal to 40 thirds, but that is approximately 13.3 repeating. Continuing on with Diego, I don't know how to go forward, so I'm going to work backwards and divide, and I'm typing into my calculator 1/4 divided by 1 2/3. And that gives me a constant of proportionality of 3/20. So I will be multiplying 100 by 3/20, and I get 15. Here is the key takeaways from today's lesson. If we identify that two quantities in a problem, and one of them is proportional to another, that just means if we identify that this is a proportional relationship, then we can calculate the constant of proportionality and use it to answer other questions about the situation. We can see the example below. Andre runs at a constant speed, it tells us it's going to be a proportional relationship. 5 meters every 2 seconds. So how long will it take him to run 91 meters? What we do is we find the constant of proportionality. To find that constant of proportionality, we work backwards and divide, because all of these problems are using fractions and decimals and pretty big complicated numbers. A lot of them are not going to be mental math, so I work backwards and divide, and I get 2 divided by 5, which is equal to 2/5. So now I know how I can go forwards. So going forwards, I would just take that 91 and multiply it by 2/5, and I get 36.4. Our goals. I can find the constant proportionality and use it to solve problems. Another goal, I can use a table to find an unknown value in a proportional relationship. With all of this practice, I hope that you can say that those goals are true. Your homework is just get caught up on all of your missing work. That's it for today. Thanks for watching. We'll see you next time.